There is a perennial conversation among athletes about the advantages and disadvantages of different stride styles and what happens when feet hit the ground while running. Recently, Correlated Solutions conducted an in-house test using digital image correlation to evaluate the strain and deformation on the sole of a running shoe during 3 different styles of foot strikes: heel, midfoot, and toe. Using this test, we can demonstrate several useful hardware and software developments here at Correlated Solutions. First, newer high-speed cameras like the Phantom VEO 640s used in this test offer high-resolution options which are necessary to obtain full-field strain and deformation contour plots in fields of view with high aspect ratios, like the thin midsole region of running shoes. The VEO 640s each have a resolution of 2,560 pixels by 1,600 pixels and a frame rate of 1,400 frames per second. On the software side, updates to the iris visualization workspace in the VIC-3D 10 digital image correlation system allow the easy juxtaposition of data from several distinct tests in a single project, exported as a 4K video. Here is an overview of the test. To accommodate the complexity of the shape, the shoes were speckled by hand using a permanent marker. The cameras were set up with Nikon 25mm lenses as close to the floor as possible. They were calibrated using a 14mm calibration target, designed and produced by Correlated Solutions. Images were acquired in the VIC-Snap acquisition software. Over 3 distinct events, nearly 2,000 image pairs were captured in total. For each type of foot strike, a separate VIC-3D project was created, and the area of interest, AOI, was drawn to capture the region of interest along the length of the midsole portion of the shoe. The goal was to compare these results in a single 4K video using the iris visualization workspace in VIC-3D 10. We've already analyzed the data from the heel and toe strikes, so we'll go through the process again quickly with a midfoot strike in the analysis workspace and then use the iris workspace to build the final video with each of the tests displayed simultaneously. We'll start with the heel strike project and use the New from Template feature to build the third project in VIC-3D using the same parameters. Select it under the File tab. This starts a new project but retains calibration and other information, which can save time when running multiple tests with the same conditions. Here, we'll uncheck the AOI box as we'll need to redraw it for this test. Next, load the speckle images and save the project. Then draw the new AOI and run the analysis. On a blank template in Iris, we'll first add a logo and a title. Then, on a new page, we'll add the 2D data from the midfoot strike project, adjust some parameters, and move the scale out of the way for a moment. We'll label this object midfoot strike and arrange the text above the 2D sequence in the middle of the page. Then we add the keyframes for time. Next, we need to add the data sequences for the heel and toe strike tests into the midfoot strike project. To do this, go to the Iris Tools tab and select Sequence Manager. Click Import from Other Project File at the bottom left and then select the heel strike test in the second pop-up. Check the box next to Speckle under Data File Sequences and then click Import. Now, do the same for the toe strike test. Click Force Update Sequence, and then close the Data Sequence Manager window. Now we are ready to juxtapose the data from these 3 tests on one iris slide. Holding Shift to select multiple objects, copy the 2D data sequence and title and paste it on the page twice. Arrange these on either side of the midfoot strike test. Change the title so we can keep everything straight. Click on the left sequence once to select. Now, we'll be working with the options in the Sequence tab in the Properties editor on the right. Use the drop-down menu to select the new project file. Click Replace to make the change. Do the same for the toe strike sequence on the right. Now, you can drag the playhead on the timeline or hit the play button to see the 3 tests simultaneously. Finish up this slide with a logo, a title, and a description. We can duplicate this slide by right-clicking in the page organizer and change the parameters as needed. In this case, we'll show the minor principal strain, E2, for each foot strike. Lastly, we'll duplicate the title card and move it to the end before exporting the full Iris project as a 4K video. Here's the finished product as exported directly from Iris. To find out more about this test, or to explore how industry-leading optical measurement systems from Correlated Solutions can impact your research, contact one of our sales engineers today. From everyone at Correlated Solutions, however your foot strikes, we wish you a Happy New Year.